Okay, let's do the AP Stat review here. Okay, let me get this out of the way. Okay, so marketing survey compiled data on the total number of televisions in households. If X is the total number of televisions in a randomly selected household, and we omit rare cases where more than 5 televisions, then X has the following distribution. What is the probability that a randomly chosen household has at least 2 televisions? So we're looking, at least 2 includes those, right? So whatever, get your calculator out. So 0.2 plus 0.11 plus 0.05 plus 0.03. 0.39 should be the answer. A certain population of students, the number of calculators a student owns is a random variable, X, described by the following properties. Wow, some students, 20% own 2 calculators. Which of the following is the mean value of X? This is your classic expected value problem, right? So it'd be 0 times 0.2 plus 1 times 0.6 plus 2 times 0.2. And 1 would be the expected value there. Again, we call that expected value E of X. It's just amount times probability plus amount times probability. Factory makes silicon chips for use in computers. It is known that about 90% of the chips meet specifications. Every hour, a sample of 18 chips is selected at random for testing, and the number of chips that meet specifications is recorded. What is the approximate mean and standard deviation of the number of chips meeting specifications? Okay, so 90% meet. Every hour, a sample of 18 chips is selected, is recorded. What is the approximate mean and standard deviation of the number of chips? So I think we should check the bins, right? Does this pass binomial? So binary, success is meeting the specification. Independent, 18 chips, they seem independent of each other. I think we don't have a reason to think that. Set number of trials, 18. And probability of success is P equals 0.9. So the formula for mean, I believe, is N times P. So 0.9 times 18, let's just do that in our calculator, 0.9 times 18. Whoops, 0.9 times 18. 16.2, so I know it's one of these guys. Standard deviation, I believe, is a square root of n p and then 1 minus p, something like that is the formula. So this would be square root of 18 times 0.9 times 0.1. 1.27, so there you go. College basketball player makes 80% of her free throws. At the end of the game, her team is losing by 2 points. She is fouled, attempting a 3-point shot, is awarded 3 free throws. Assuming free throw attempts are independent, so we're making that assumption. What's probably she makes at least 2 of 3. So we do have a set number of trials. This does pass the bins test. Right, so now we know, I like to just label everything. So 2 out of 3, so n is 3, x is 2, or 3, right? So x is, we're finding the probability that x is greater than or equal to 2. And then p, the probability of success is 0.8. So I would use your calculator probably for this one. Just seems easier. So menu 5, binomial CDF, because we have a range of values here. Our number of trials is 3. Probability of success is 0.8. Lower bound is 2. Upper bound is 3. 0.896 should be it. random variable x has a mean of 50 and a standard deviation of 12. Y has a mean of 15 and a standard deviation of 5. They're independent. Find the mean and standard deviation of 3x minus 4y. So I think multiplication affects standard deviation, affects means. So this would be 3 times 12 minus 4 times 15, whatever that is. 3 times 12 minus 4 times 15. Wait, means, what am I doing? 50, mean of 15. Sorry, wasn't paying attention to the numbers very good. 3 times, something didn't seem right. 4 minus 4 times 15 is 90. So we think this is not right there. Okay, so which one of these guys is it? So we've got to find the standard deviation. This one takes a little thought. So we're combining. When we combine, adding or subtracting, we always add and we square them, right? So 3 times x, in this case, the standard deviation is 12. So 3 times 12, and this is minus going to be, now this is not going to be the answer, 4 times 5 there. So this one is 36 and 20, but we can't just subtract those two guys. In fact, we take the square root, we change into variances, so 36 squared plus 20 squared. That should give us our answer here. So square root of 36 squared plus 20 squared. $41.183. I think that's it. Whew, that's a tough one. Vending machine operator has determined that the number of candy bars sold per week is a random variable, the mean of 125, standard deviation of 7. His profit, each bar sold, is 25 cents. It cost him $5 per week to maintain the machine. So I think you're doing a machine like the profit is equal to 0.25 times each bar sold. I don't know. I guess this is Y, right? I guess we're going to call it X. Minus the $5 cost. Okay. So we're going to plug in both subtracting and multiplying affects the mean. So if we plug in 125 there, we would get 0.25 times 125 minus 5. 26.25, so I think it's one of these. Then standard deviation is not affected by the minus 5, so it would be 0.25. 0.25 times the standard deviation is 7, so 1.75. So I think it's E. This is the binomial theorems written in a very formal way there. So I like to label what stuff is. So 10 is the n value, x is 3, and the probability of success, when I get 7, there's 8 possibilities. So 1 out of 8 times. So 10 and 3, so I know it's one of these guys. These are out. Oh man, what's the theorem for that? Okay, so the formula is we already have the 10 and 3. That means NCR or 10 choose 3, by the way, times 1 minus P, so 7/8 to the K, which is like X, times 1/8 to the 10 minus 3, or 7 power. That's 7. 1/8 to the 7th, 7/8 to the 3rd, 10/3. Yeah, it's this guy. In order for the random variable x to have a geometric distribution, which one of the following conditions must x satisfy? Okay, so P doesn't, let's get rid of the bad answers. Like that one doesn't make sense. No, for geometric, that's for binomial. N trials, we don't have N trials. Like we don't have a set number of trials. Outcomes don't, failure could be different than this one. This has to be it. Probability of success has to be the same for each trial. That's true. P is the same. It's one of the requirements for VINs. And again, N is not part of geometric, but that one is. At a school of 600 students, 25% of them walk to school each day. If we choose a random sample of 40 students, it is appropriate to model the number of students in our sample who walk to school with a binomial distribution where N equals 40 and P equals 0.25. So we know it's binomial. Oh, wait, no. Is it appropriate? I don't know. Let's see. Does it pass the bins? So I guess walking to school is, or not walking to school is success or failure. Okay. Independent. Choose a random sample of 40 students. Seems independent. N is 40. Same probability of success, 25%. Yes, because the sample size is less than 10%. Ooh, so is that true? Yeah, that's true. I think that's probably it. I'm going to check that one. Nice. Yeah. A jar has 250 marbles in it, 40 of which are red. What is the largest sample size which we can take from the jar without replacement if we want to use the binomial distribution to model the number of red marbles in our sample? So 25, right? That's 10%. Picard Partners is planning a major investment. The amount of profit X is uncertain, but the research department has provided the following probability distribution for X in millions of dollars. The mean. So how do you find the mean? It'd be 1 times, this is just expected value, right? So 1 times 0.2 plus 2 times 0.5 plus 4 times 0.2 plus 10 times 0.1. So 3. We would show the work I just typed in there. You're going to show the work there. Interpret the mean. So if we profit X is uncertain. This is in millions of dollars. Okay, so if I want to interpret the mean. Interpret the mean, so $3 million. So I'm trying to say, if we took X many, if we sampled the amount of profit from Picard Partners many times, the average would be 3 million. I need to look that up, make sure I'm done right. This kind of investment was made many times. The average profit would be $3 million. Okay, it's not terrible. I'd interpret the mean and standard deviation, right? So standard deviation for this one would be square root of, you know what? Why do it by hand when you can use your calculator? So go to a new document. So this is profit. This is prob. 1, 2, 4, 10. 0.2, 5, 0.2, 1. Okay, go to calculator page. Menu 611, one variable stats, profit, prob. So standard deviation is 2.529. Interpret this. So if we made many investments at Picard Partners, the typical variation from the mean would be about 529,800. See what they said. I just want to see their answer. If many of these investments are randomly selected, the profit will typically vary by about 2.53 million from the mean of 3 million. Okay, so for this one, so we're multiplying by 0.9 and subtracting 0.2. So both of those things affect the mean. So 3 times 0.9 minus 0.2. The new mean is going to be 2.5. You're going to show that bit of work, by the way. I'm just doing it on the calculator. You want to show that work when you do this. The mean is standard deviation of y. So standard deviation, what is that? How is that affected? So we have this 2.5298. Let's see, only multiplication affects it. So times 0.9 is standard deviation is 2.2768. And do that again, interprets here, okay. Company offers gift boxes containing 4 pears and 5 chocolate truffles with an advertised weight of 800 grams. The weights of individual pears can be modeled by distribution with a mean of 188, standard deviation of 6. The weights of individual chocolate truffles can be modeled by a distribution with a mean of 12.5, standard deviation of 0.7 grams. Can be modeled by a distribution with a mean of 20, the weight of a box. So this is a box, 20 grams, and standard deviation 0.9. Assuming that the weight of the individual pears, chocolate truffles, and boxes are independent, calculate the mean, the standard deviation of the total weight of a gift box. So let's start with, so I'm going to do my calculator, and you're going to show this work in your paper. So we have 4 pears times mean of 188 plus, oops, five chocolate truffles times mean of 0.7 plus 0.9, right now mean of 20, I guess. That looks funny. So let's see, 188, 12.5. Okay, I think calculate the mean of the total weight. So 834.5 grams. I'm going to check number 12. 834.5 grams. That's correct. Standard deviations you cannot just add, right? So you're going to have the 6 grams, make it variation, plus 6 grams, plus 6 grams, plus 6 grams, plus, the next one is 0.7, so 0.7 squared plus 0.7 squared. There's 5 of those guys for chocolate truffles. 0.7 squared plus 0.7 squared, plus 0.7 squared. And then finally, the box is going to be just 0.9, so plus 0.9 squared. You're going to type that in, square root the total, type that in your calculator, see if they did that. They did, yeah, they did do exactly that. They got 12.135 grams. An online poll reported that 20% of students subscribed to the 5-second rule. That is, they would eat a piece of food that fell on the floor. It picked up within 5 seconds. Let's assume this figure is accurate for the entire U.S. population. We just select 15 people at random from this population. Let F equal the number of people who subscribe or agree to the 5-second rule. Determine the probability that exactly 3 out of 15 subscribe to the 5-second rule. Okay, so I'm just going to write out what you could type in your calculator. So NCR, whoops, so N is a number here. So 15, choose 3, times probability of success, which is 0.2, to the X, which is 3, times failure, which is 0.8, to the 15 minus 3, or 12th power. So I think if you type that in, let's see if that's what they did for 13. Yeah, you can see right here, they did that and they got 0.2501 when they typed that in their calculator, basically. You could also have used binomial PDF for that one. I'm going to do this next one in the calculator because I'm not crazy. Fewer than 4, so probably that X is less than 4. So get your calculator out for this one. So menu 55B, I believe. So N is 15. Probability of success is 0.2. Lower bound is we want less than, fewer than 4, so that means 0 or 1, I guess, is probably the lowest. Upper bound would be 4, no, 3 actually, right? So 0.6129. They got 0.6482. So I changed my lower bound to be 0 and it worked out. So why can that be 0? Let's look back at the problem. Let's assume the figure is accurate. So is it possible to get an answer 0, right? That's certainly possible, that no one subscribes to it. So I should have put in a 0 there the first time. There were a few problems where one was the lowest. I don't know. I was thinking that, but not quite right. I'm trying to interpret the expected value of F. So expected value of F. So this is binomial. So that's going to be N times P, right? So N would be 15 times the probability of success is 0.2. So 15 times 0.2 is 3. You want to see that little bit of work there. How to interpret the standard deviation of F. So square root of NPQ 15, probability of success is 0.2 times 0.8, whatever that is. If you do part D, let's see if we have that one. Yeah, they typed it in right there and they got 1.55. If many groups of 15 were randomly selected, the number of people groups who subscribe to the 5-second rule would typically vary from the mean by about 1.55. Whitney Pete, a professional dart player, has a 70% chance of hitting the bullseye on a dartboard with any throw. Assume that each throw in the dart is independent. Suppose that Pete throws a dart until he hits his first bullseye. Find the probability that his first bullseye occurs on the third throw. Okay, so this seems, I think it's his first bullseye. So this seems geometric, right? So for this third throw, I'm going to just do it the old-fashioned way. So I want him to miss 0.3. I want him to miss. And the third throw, I want him to hit. So you would type that in your calculator. There you go. And you get 0.063. You also could use geometric PDF to get it as well. Which is probably Pete hits the bullseye in 5 or fewer of his next shots. So you definitely want to go to the CDF command here for geometric. So menu 5, geometric CDF. So probability of success is 0.7. Lower bound, I want it to be 5 or fewer. So 0 to 5.997. Oh, I didn't use, this is not geometric, is it? 5 of his, or fewer of his next 10 shots. This is now binomial. We have a set number of trials. Got to think about it. Okay, so 5, binomial CDF. The number of trials is 10. Now we have a set number of trials. Probability of success is 0.7. Lower bound is 0. 5 or fewer, there will be 5. So 0.1506. Yeah, 1503. Yeah, we got it. And then part B, or C, I guess. Pete forgets his eyeglasses one evening, but he's confident he's just as accurate without them. On his first 10 shots, he hits the bullseye only 5 times. Is there convincing evidence that his glasses are important? How unusual is it to get 5 out of 10, right? So let's go to menu 5.5a. So we want out of 10, we want to get probability of success is 0.7, and we want to get 5. There's a 10% chance of that happening. Not that unusual, right? So we don't have enough evidence. It's not less than 5%. So you would show this work and explain that there's a 10% chance of that happening. So it's not that unusual. That's your lesson for today.